Now our next topic is consumption decision in terms of net demands. I would request you to study this topic after the topic that was the offer curves and net demand curves, because you will understand it much better if you check my lecture of offer curves and net demand curves. Okay. Now, as a microeconomist, we are always, as an economist, basically, we are always concerned with the optimization problems. That is, if you want to maximize variables like revenue or profit or satisfaction, we should find out that point where the consumer's satisfaction is highest, the firm's profits are highest, the firm's revenue is the highest, okay? Or the losses are minimum or the lowest, the cost of production is the lowest. So the consumption decision in terms of net demands starts with the consumer's optimization problem, where the level of consumption is taken for the goods like let's suppose that the given number of goods are x1, x2, x3. Okay, let me just correct this one. Sometime soon I will be purchasing that pen for these lectures so that my writing is in a much better quality for my students. So these are the n number of words. When we're studying real numbers, real concepts, what happens is this. Then what happens is that we take n over here. That is, n is any countable number of words. When we take infinity, we say that those words are not uncountable. They cannot be counted easily. So therefore, consumers optimization problem, the level of consumption of goods x1 till xn are given, and they are treated as choice variables. Okay, from x1 till xn, they are all treated as choice variables. Now, it is also possible to formulate the problem with consumers' net demands. We have studied the net demands in the previous lecture. What were the net demands? X1 star, okay. Then the net demand for good 2 was x2 star. Then we had x3 star. And then, of course, again, if you want to study the net demands for n number of goods, then we will have xn star or hat, okay. What next do we have over here is consumer's utility function. That is ux. It can be rewritten now. This ux or utility function can be rewritten as the function of net demands. Okay. Now, if you want to study the net demands of n number of goods, what will happen is that you will write it as xi hat. Okay, is this fine now? Okay, let's call it hat instead of a star. So therefore, when I say hat, I mean by this particular symbol. Now, xi hat, we know that before proceeding to the utility function, we should know that what is xi hat. Xi hat, because this particular variable is used for the net functions, net demand functions. So therefore, what will happen is that we will have a difference of two demand functions. One is xi and the other one is xi bar. As I told you that in order to understand this lecture completely in detail, you should check my previous lecture. That is the lecture of offer curves and net demand curves. So now we have xi hat is equal to xi minus xi bar. Therefore, we have xi, okay, is equal to, okay, xi hat. What happened is this, we have left this particular variable on the same side and we have moved xi bar to the left hand side. Therefore, xi is equal to xi hat plus xi bar. Now, this is important to understand, okay? Therefore, utility function u of x, it is equal to u of x1, comma, x2, okay, wait. u of x1 comma x2 comma x3 till xn. Clear? Now this is equal to, okay, this is equal to u into, that is utility function of x1 hat. Where now what do we mean by this x1? This is x1, okay? Say this x1 is equal to x1 hat plus x1 bar. Clear? If we take the value of I is equal to 1, okay, let I is equal to 1, then x1 is equal to x1 hat where plus x1 bar. Okay. Now if we have this I is equal to 2, let I is equal to 2. I'll just do it for these two i's and then I hope you'll understand how I will write that other equation. And then x2 is equal to x2 hat plus x2 bar. Okay. So therefore, in place of x1, we will write x1 hat plus x1 bar. Then we will have a comma x2 hat, okay, plus x2 bar. I hope now you are getting my point. We are substituting these values over here and so on. And therefore, similarly for xn, we definitely know that it should be xn hat plus xn bar. Xn hat plus xn bar. And again, now let us suppose that this is equation number 4. Okay, let me not write it so that you may not be confused with this. Since the initial endowments, that is xi's, are constant, therefore u varies only if this net demand varies. Clear? The initial endowments are constant. We know this very well through the assumption. Therefore, what will happen is that the utility will vary, the value of u or the utility will vary only if xi hat varies. Clear? If this particular value varies, utility will change only if xi hat will change. Okay. So therefore, now next what we will have is we will have u, okay, x1 hat, okay, plus x1 bar. Oh, we have already written it, so therefore there's no need to write it again, with slight changes as well. Okay, now what we have over here is, therefore, curly, because there are n number of choice variables. Choice variable starts from n1 and then ends at n. Therefore, there are n number of choice variables. So therefore, we will take partial derivatives. Therefore, we will have curly u hat upon curly xi hat. This will be equal to curly u. Now just have a look at it. Now it will become curly u upon curly xi hat. Okay, this is also hat. I hope it's clear to you. It will become curly u upon curly xi hat is equal to, here we have curly u hat, okay, divided by curly xi hat is equal to curly u upon curly xi hat, and this whole is equal to now curly u divided by curly xi hat, okay, multiply by curly xi hat divided by curly xi. Curly xi is equal to, now this whole is equal to curly u upon curly xi. Okay. partial derivative of the utility function, net utility function, with reference to the partial derivative of the net demand function is equal to partial derivative of the main utility function with reference to the partial derivative of the net demand function of the I goods. It should be equal to the partial derivative of the utility function main or original utility function to the partial derivative of the net demand function of the I number of goods multiplied by partial derivative of, again this value will come over here, multiplied by the partial derivative of the I number of goods, clear, net demand of the I number of goods to the partial derivative of the given I number of goods. This whole should be equal to partial derivative of u, that is the original utility function, to the partial derivative of the I number of goods x. Therefore, what we will get is that this u hat that is written over here, now this u hat will have all the properties possessed by simple utility function, such as continuity, quasi-concavity, okay, like it should be a downward sloping curve and all this. So this u hat possesses all the properties of utility function. Net utility function possesses all the properties of this same utility function. Then feasible set can also be rewritten in the form of xi hat. The feasible set that was given, it can also be rewritten in the form of xi hat. Clear? Now, over here I am referring to the equation that was that I told you earlier. And what was that? Okay, let me write it again. Now, what I'm saying over here is that the feasible solution can also be written in the form of xi summation pi xi hat. Okay, and it is equal to, because this is xi hat, this is the net demand function, therefore it should be equal to summation pi. What comes in place of xi hat? It should be xi minus x bar. Xi minus bar generally refers to this xi hat. Okay. So what happens next over here is that xi is equal to, we also know that xi, if we let this xi on the same side, xi is equal to xi hat plus x bar. Okay. Xi hat plus xi bar. Okay. Okay. So therefore, we also know that xi hat, it should be greater than or equal to minus xi bar. This xi hat, it should be greater than or equal to minus xi bar. And of course, we know that the value of I is equal to, or I starts from 1 and it can end to any n number, showing that the supply of goods cannot exceed the endowment of the goods. Therefore, what does this equation show? The supply of the goods cannot increase the endowment of the goods. Therefore, optimization problem in terms of net demand as compared, okay, well, it can be rewritten as. Now, what we will do over here is that we will write the optimization problem for the net demand functions. That is for the net utility function. And how is the utility maximized? By demanding those goods which gives the consumer highest level of satisfaction. Therefore, the optimization problem will be written as maximize u hat given x1 hat, comma, x2 hat. Okay, this is x2 hat till xn hat. Okay, then it is subject to, or you can say that the constraint that is given over here is that the budget equation or the budget line, which states that summation pi xi, because consumer has budget, and within that budget he can purchase or consume his goods. It is either less than or equal to 0. And also over here we have derived that xi hat is greater than equal to minus xi. This can also be one of the constraints. and I is equal to 1 to 3 till n. Therefore, this is the derivation of our consumption decision in terms of the net demands. Then after this, you can also move towards the Lagrangian functions and then move towards the first order and second order conditions as well. So this is the explanation of the consumption decision in terms of net demands. And I hope it is clear to you till here. If it is clear till here, then after that we will move to our next topic. And I'm telling you this in the end of this lecture because I want you people to check the expenditure function lecture after this lecture so that you understand the expenditure function also very well. Okay, for now, let's finish this lecture over here. If there is any question, you can ask me. Thank you.